Ah,
Quindi, bene, buon pomeriggio. Questa è una presentazione della laurea magistrale in ICT for Internet e Multimedia. Prima domanda che vi faccio è, va bene se procedo in italiano? Is it okay if I proceed in Italian or should I switch to English? English. Okay, very good. I hope that is not an issue for Italian speakers. It should not, in the sense that our master degree is in English. So, and this is the same for almost all the other master degrees in this department. We are very aligned on this line since a while. The master degree in ICT for Internet and Multimedia is a course that is providing a variety of contents and has multiple objectives, let's say, inside it. So to give you an idea of what is your activity at the end as an engineer that has a master in ICT for Internet and Multimedia, I picked here a couple of examples, giving you the kind of full picture of a couple of relevant chains in the area of communications and multimedia that are two pillars of our master degree, just to give you an idea of what is going to do an engineer that is graduated in ICT for Internet and Multimedia. Here, what is shown in this diagram is the various roles that a telecommunication engineer, so someone that is centered into the topic of telecommunications, is doing in the context or in the application, if you want, in what we see at the end as user of a cellular network. So every one of us has a cell phone, even more than one, if we stick to the statistics. So what is behind this, which is the technology which is behind this? But rather than telling you what are the technologies that are behind, I will tell you which are the roles that you may take as an engineer in the whole process of having this network and these cell phones working. So we start from the definition of the standards for a telecommunication standard like the cellular networks. You have people that sit in the room and agree on what should be the interfaces, what should be the signals that should be transmitted, what should be the radio frequencies at which we should transmit, and all the details, the protocols, and so on and so forth that should be used because it's a standard. So many people, many companies can do their own product, and all these products should be able to collaborate between them. So there is a first stage in which the standard is designed. For the cellular networks is the 3GPP. For internet, you have the Internet Task Force. So you have an equivalent kind of bodies that define what is TCP, IP, what are the protocols that goes on internet. So this is just an example, but this also maps to many other situations. Here, there are engineers that sit in this room, and for one engineer sitting in the room and agreeing with the others, there are many behind that are actually supporting this representative to convince the others that their solution is better. Companies here are big manufacturers, Qualcomm, Nokia, Ericsson, Huawei, whatever you want to mention. Operators, so the one that provide us the services because they will be the users at the end. Stakeholders like a representative from the states and the government, technical representatives that collaborate in this process. Engineers, if you're not an engineer, you don't have a clue of what is the discussion happening here. Telecommunication engineer, so someone that has a background given by our people. Then, once the specifications are set, we go to the implementation, to the first design of base stations that are things that are fixed and provide us the service, and the cellular terminal, so what we have in our hand. And here, of course, you have a hardware and software solution that should be deployed according to this specification. But this specification just make sure that different companies and different devices can talk together, while the specific way in which you implement what is done in each hardware and software block is your invention, the invention of engineers working for companies that then implement these things. There are many ways you can do these two things. Many of the equipment that you see are done by big corporations that have branches also for design of these parts, basically all over the world, including Italy, including Europe. Of course, some of these companies are from Europe, others are from all over the world, so it's a really worldwide context. Then we have niche solutions where these hardware and software are done in a particular way, and you have to go just to Vicenza, which is a city nearby here, Padova, and you will find a company that is doing this part here of the base station and what is behind, so the network infrastructure based on software in a rather innovative way for niche reasons, also with specific targets into their mind. So you go from big companies to smaller or medium companies that develop niche applications that are very important. And in all these cases, you need engineers that are working, that have this expertise of telecommunication engineers that you have in the Master of ICT for Internet and Multimedia. Why it's very specific? Well, because here you need to have knowledge of your radio propagation. You have to have knowledge of protocols over the networks. You have the knowledge of what does it mean to let two terminals to talk to each other and dealing with the bit error rates, packet error rate, and whatever. So it's a mindset, it's a way of looking at things that, of course, use tools from mathematics, from software design, from hardware, but it's a different perspective that put all these together with the specific objective of having a communication system working. And if you don't have a specific background on this topic, putting all the pictures together to get the full picture takes time, the time you need to do the master, right? So then you have apparatus production and testing. Once these things are done, you have to test them and make sure that you may want to integrate them. Our phone is self-standing device, but if you start using the cellular network in an industrial application to let robots interact with each other, then you have to customize the solution and integrate the communication solution of a cellular phone with other equipment. Then, from perspective of the network definition, you have to decide where to put the base stations. And apart from the regulations that will force you not to put the base station everywhere, you also need to ensure that the whole area is properly covered. So is a quite delicate process here. There are specific softwares that support you in this planning of the network, so deciding where to put the poles, but it's not trivial. And of course, you should be able to understand how this software works, which are the results that are given to you, and so which is the best solution for to do this. This also, by the way, is applied also in other contexts. You can have a Wi-Fi network planned and designed like this, where you need to understand what is the concept of quality, for example, the tickets. Network size engineer, so you have to dimension the network. We have a proper network that is able to support so many users with this data rate. Distribution installation, with the physical part of installation is not done by engineers, but there are engineers that supervise this part and make sure that control the process, for example, and revise the equipment so that if something goes wrong, because those that are installing the antennas typically do some errors, well, they revise also the way in which this installation is done to avoid such errors. Then, of course, you have the control, the quality monitoring. So you have to, once the network is deployed, you have to check that everything is working fine. So you have the maintenance, but it's also the quality monitoring. So continuously checking and overseeing that everything is run in place. We go from research activity, kind of things that, of course, typically requires also a PhD after the master, to more and more implementation and quality assurance activity that are more far from research, somehow a bit more routine, but there is a lot of expertise also there, and there is a huge market in terms of need of engineers for all the steps that you see here. So this is just an example. The other example is taken from the multimedia engineer. So the other phase, one of the other phases of our degree, which is multimedia engineering for industrial control. Here we focus on audio and video processing that is needed in order to complement the industrial application so that they can benefit from the visual and audio information that, for example, may come up by observing the production line, whatever is under production. So there is a lot of automation here. You have AI, smart processing, and the AI. You have to work and understand how the acquisition devices are done and how which are the errors, let's say, and the imperfection that they introduce, so that you can compensate them with a smart processing here. So you see, for example, here that there is a significant component of AI which is tailored to image processing. There is a lot of requests of such things because, of course, automating the production and using visual aids and AI to understand if the production is going well is a great asset that reduces the costs, for example, for the production, and is very important. Then there are other parts here. So you have to do the integration of your hardware and software components into the industrial components again. Understand how to optimize the various flows. So here there are very important protocols, for example, for the transmission and storage of images and videos. That is very important in order to optimize, to deal with, for example, with the fact that you have many cameras who would like to collect a lot of videos, but then there is some bottleneck because, for example, you want to go over Wi-Fi, and then you have to understand how to compress the data that is collected by the devices in order to go over a medium that is quite restricted. And there is a part of visualization, let's say, and interaction, where you have keywords like artificial reality, virtual reality, augmented reality. And in this case, of course, it's quite challenging because one of the main challenges there is that you would like nice pictures going live, so it's a kind of a video smoothly, but to obtain such smooth and nice videos, you need to put together a lot of data, a lot of information. So again, you face bottlenecks that are now maybe related not to your communication device, but to the computation capabilities of the device that maybe just a couple of glasses. So you cannot have super powerful servers on your glasses, as you may understand. So there are a lot of constraints that force people to design proper protocols and design solutions that are very tailored for this. Engineers all over. Any single steps here is done by an engineer. And again, it's not like an electronic engineer, not enough because he knows the silicon here. It's not enough a computer science engineer because he may be very much of an expert of software in general, but not multimedia application like the compressing part, like the AI for images and elaboration of images. May not have enough knowledge of the hardware components that should not be known in details. So we don't need to go to the movement of the electrons on the silicon, but to understand what are the main characteristics and the main problems there that should be fixed, for example, then with suitable processing. So it's a matter of different vision of hardware, software, and the idea that all these things should go together with a specific target, in this case, multimedia and signal processing. So these are just two examples. Here, just to recall that what is ICT is information and communication technologies. Here you have a word cloud, where we put together some words that are related to ICT, information and communication technologies. You see that you have networks, you have internet, which is in the title of our master. You have communication, of course, which is very important because it's the infrastructure of ICT, wireless, broadband, and other things like, well, many other things that now I don't spot that there should be, and maybe is getting larger and larger as time goes on. For example, issues related to security that we are also covering in our master. Which is the core structure, generally speaking. So we have the solid mathematical background, which is given to you mostly by the master degree, but also there are some courses that are more fundamental and give you some, basics on tools that are needed across this discipline. Then you need some other cross-disciplinary tools that are like programming, machine learning, optimization theory that are clearly important for many disciplines, not just for telecommunication, but at the end, they are at the foundation of the rest. And for example, they can be declined in the correct, put in the correct version for telecommunication. Some software tools are more relevant for us than for bioengineers, electrical engineers, or others. Then we have specific ICT technologies, where we have main topics: communication networks, multimedia, transmission methods, and security. Security is also important again. And on top, then you have the applications that are driving all this towards this end. Mobile networks and Internet of Things are kind of generic, providing the architecture, the infrastructure for communication. ICT for health, you have a further specification where it's ICT for health, and so you have an application that goes outside of the domain of communication technology, which is the health purpose, which is of course driving further driving your attention there, and it's some more information, some more concepts and knowledge are needed there. Industry 4.0 is also another example where you integrate the communication path into the industrial path. The structure of the course is the following, which is common also to other courses, but anyway, this is what we have. The course is completely taught in English. We have typically 6 compulsory courses for 36 credits, 3 characterizing courses that are typical of the curriculum in which you are inserted. So characterizing courses in Italian is corsi caratterizzanti, so it's what is relevant for the specific class in which the master is inserted. Then you have 3 related courses, affini in Italian, which means that are courses that are not immediately related to telecommunication, ICT, but they are important to complement your skills. They are, by the way, compulsory in our structure of the courses in Italy. So you also have to widen a bit your sight and see something else that is not exactly centered to what is the main topic of the master. 2 pre-courses that you can choose as you want for 12 credits. Then you have the possibility to complete your then you can have either an internship or a research training. Internship is a period that you spend with a company outside of the university, and what you do there is recognized as 9 credits. Or you can do this time in a lab of our department, of our university, and if you think that what we do here in terms of research is interesting, we are very welcome to open the door and let you in and work in a more advanced way on specific topics. Final thesis, 21 credits. By the way, many cases, many people, many students do these 2 things of internship, research training, and final thesis together. So they do a thesis that is done in a company, so part of the time is officially spent as a literacy, part of the time is officially spent as the final thesis, or they do the thesis with the department and they extend it, including the research training there. It's not compulsory to put these things together, but it's a common. If you check, this is 30 credits, which is 1 semester. So out of the 4 semesters that the master is long, 1 semester goes for the thesis and the internship. Have a look. Let's have a look to the courses that you find, the caratterizzanti, so those that are characterizing the master and those that are affini. Here is a list with some connection with them, where you find mobile communications, that is talking about the example that I gave you, fiber optics, that gives you, understanding and fundamentals of how the fiber optics works and how they can be integrated into a communication system. Computer vision on the side, let's say, of multimedia, wireless networks, still communications from the perspective of neural networks, and deep learning. AI is very important. I will tell you more about this, but clearly AI nowadays is very important. So you can also extend your, have also solid basis here. Stochastic processes is one of these fundamental basic courses that is giving you the background, kind of a bit more mathematical, but it's not mathematics by itself, is mathematics and tools that you immediately apply to communication scenario and to understand how to model and how to characterize the network, for example. Antennas, very important devices for a communication system. Digital communications gives you all the fundamentals of the algorithm by which you do the signal processing of the signal that you transmit and you receive, wireless, fiber, whatever. Bioelectromagnetism, which is related to the track on e-health as a course by itself, and so on and so forth. In the Internet of Things, and you see the others. Corsi affini, these are the courses that are related. Here you go from convex optimization, that gives you a background on optimization, which is very important in many contexts of ICT, to big data computing, to go optimization methods here, quantum information computing, there is also part related to quantum in our courses, ethical action about security, cyber physical system, and IT security. So you can complement your background of the courses that I listed before in this sense. The master degree is organized in 6 different tracks, 6 different curricula: communication technology, cyber systems, research and innovation, multimedia, ICT for life and health, and AI. Let's see them in detail. The communication technologies deals with what are the basics and fundamental technologies of communication in general. Nowadays, typical communication networks. So to go from the hardware part of fiber optics antennas, wireless, both in terms of hardware, but also in terms of modeling of the propagation. So how the signal propagate on air, and how can you then process them once you receive. MIMO, which is multiple input, multiple output. So what happens when you have multiple transmit antenna and multiple receive antenna? This is a key technology all over in communication systems now. Your modem, Wi-Fi modem, has multiple antennas. Your phone, if you open it, I don't suggest you to do it, but just make sure that you are able to close it again after, has multiple antennas inside. All the base stations have multiple antennas, because these multiple antennas allow to direct signal in specific directions. So this is the meaning. Smart surfaces are advanced hardware that will be used in the future, so I don't go into the details. Quantum communication, very interesting, very promising, quite new, is also present. And in particular, you can go into deeper understanding of quantum communication if you do this practice curriculum on communication technologies. Still in this curriculum, you have also, so this is a kind of toward the hardware. Then we go up and we go toward the networks, or more, let's say, the software. So you have mobile networks, 5G, 6G, so how they work in terms of software protocols that you have there. Wi-Fi again, but we also go to submarine and satellite networks. Submarine is also audio networks. We have a group of experts here that is particularly working on this point. Same for satellite networks. They are, by the way, exploding right now. There is an excitement, new excitement for space in all senses. Here you have both the network for the communication, but also the network for positioning, so GNSS and so on, the expertise that we have in our research activity that is reflected into the courses that you have. So you can find immediately courses that are related to this. Second track in cyber systems. This is more specifically tailored to the software part. So this is a bit more across with a focus on the hardware. This is a more, let's say, specific and more tilted towards the software part and the network. So you have Internet Access Protocol, cyber security. Here you have an accent on security. Again, Wi-Fi, but also Internet of Things and industrial communication. So you can see is like this part extended and actually complemented with other components. Multimedia. Multimedia is, for example, what I introduced you to before. But so definitely we have machine learning, artificial intelligence for point cloud and video analysis for the reconstruction of systems. So you can imagine all these things of face recognition, biometrics, which is exploding. There are many companies that knocks on our doors and ask for this expertise. Video, images analysis and processing, and network transmission. They need to compress signals in order to fit with the size. So there you have also artificial augmented reality, virtual reality, and these kind of things. ICT for life and health. This is tailored towards health applications. So processing and transmission of human and biological signals, analysis of human data using ML AI techniques. So here the track is towards the application of signal processing in the health context. Research and innovation. This is a curriculum that has been created for those, let's say it's more fundamental. It gives you more fundamental courses that are important, both if you stop after the master, because then you have a more solid and across many domains view, and in particular, but not exclusively, if you want to do a PhD. All the other tracks are also suitable for a PhD, in the sense that they are very suitable if you want to do a PhD in the topic that is related to the others. This is a bit more open, it's a bit more fundamental, considering that you will, if you plan to have 3 more years of study afterwards, well, you can spend time to dig into more general and basic topics that will give you tools that you can apply in any context. Otherwise, you can catch up with these topics. Artificial intelligence, this is a special and new curriculum that we have inserted. You will find artificial intelligence curricula in most of the other master degrees that we offer here. And in fact, the decision of our department has been that, AI is very important nowadays, but we concluded that it doesn't make sense to create a specific curriculum, a specific master course on artificial intelligence. Why? Because the importance of AI is also related to the fact that you can apply it in many contexts, every time with its own characteristics, with some common elements. But what is important here, and what we wanted to give accent to in our organization, is that you need also some other competencies in one specific field, in this case ICT, so communication, multimedia, these kind of things, on top of the knowledge of AI. Otherwise, you probably won't be distinguished by many others that say, I know AI. So the idea is that every single master, in almost all the masters here, have a track, a curriculum on artificial intelligence that has a bunch of common exams that are common to all the students in our department that are doing the AI track. So we will be together with other people of other master courses in our department doing exactly the same exams. These are the fundamental courses that we think that are key for those that really want to know about AI. And then on top of this, you can complement these fundamental courses with the specific courses that are already tailored, that are already give you application of AI in specific domains. So in our case is communication, security, image. I already stressed that in the area of image processing, AI plays a very important role. So here you have the vision, computer forensics, and biometrics, and ML AI for human data. So it's a mixture of exams that are common to all the students in our department that are doing a curriculum on AI and specific to us. Our department has a lot, as you can see, 48 research labs, 11 teaching labs. You will have access to both of them, in particular for the thesis, for the research training for the thesis. You can access the research labs, but also during the regular courses, apart from the teaching labs. Of course, in the master, we are talking about advanced topics that are very much related to our research activity. So whenever there is the relevance and importance for you to enter into a research lab and see something that is done there and do something, of course, you get access. Last slide, which somehow reconnects me to what I started with, is here very short list, of course, just a few faces with names and the roles that these people have nowadays after they graduated in these rooms in telecommunication engineers and what was that evolved over the ages, over the years for telecommunication engineers. You can see some names that you may know, like Vodafone, I think you know, HP Enterprise, Airbus, I think you know. You may not know, for example, Qualcomm, which is a company working in the domain of satellite communications, particular position here, Bassano and Grappa, so not far from here, and others that's are also possible. As you can see, engineer, cloud architect, engineer, and head of research and innovation. So of course, they are doing engineering activity over there. With this, I concluded my presentation. It's time for you for questions. You can ask, of course, in English or in Italian, as you prefer. And I'm here to answer your questions. If you have any. There are also some of my colleagues spread in the room that may complement what I can say. Please.
Ci sono però sì, non ho visto quello sì, sì. È prevista per fare un'attività, diciamo, di orientamento per fuggire dei corsi di studio.
Sì.
Ci sono moltissimi corsi di varie specializzazioni, però cercare di creare un profilo anche per il Stato, perché penso ci sono.
Allora, io rispondo nella lingua in cui mi fate la domanda. I curricula che abbiamo disegnato, questi 6 curricula qua, sono stati rivisti nel corso degli anni e nella loro versione attuale presentano una struttura molto solida, per cui ci sono degli esami obbligatori. Lei sceglie una di queste 6 opzioni, diciamo, e la scelta di queste opzioni è dettata ovviamente sia da guardare, diciamo, quali sono gli esami che trova lì dentro, ma anche un po', diciamo, dal titolo e da una loro presentazione generale. Abbiamo un sito che è indicato qua sotto che vi dà una descrizione più dettagliata anche di vari curricula, eccolo qua, minddayunipd.it, quindi qua trovate ulteriori informazioni. E quindi una volta che ha un po' individuato 1 o 2 curricula che sembrano di maggiore interesse, poi troverà che in ciascun curricula ci sono dei corsi obbligatori e questi le danno, diciamo, quelli che noi abbiamo ritenuto essere delle conoscenze fondamentali anche naturalmente in un contesto del mondo lavorativo, e degli esami che invece può scegliere lei liberamente. Abbiamo dato, diciamo, può fare un po' quello che vuole lì, quindi se ha bisogno di un aiuto ci siamo, perché c'è un responsabile dei piani di studi che la può aiutare e dare tutta l'assistenza che vuole, però mi viene quasi da dire che, ripeto, se anche va in libertà e va a scegliere quello che le sembra più interessante, ecco, naturalmente indicazioni generali possono essere che se sta un pochino in un filone di argomenti, quindi se mette 2 o 3 esami che sono legati più o meno lo stesso argomento, probabilmente si trova meglio, se l'argomento è di interesse ovviamente, che non prendere una cosa qua, una cosa là, perché se ci sono degli esami che sono vicini come tematiche, avere fatto un esame prima l'aiuta a fare l'esame dopo, quindi cioè, le dà una visione, chiaro che le dà però anche una visione più concentrata su quell'argomento, quindi uno può dire no, io voglio andare a fiori e prendere una cosa qua, una cosa là, perché voglio avere una visione più generale, oppure posso concentrarmi un po' di più. Vi lasciamo liberi in questo senso perché i paletti che abbiamo messo in termini di esami obbligatori per noi sono sufficienti per garantire la qualità e la lista degli esami a scelta da cui potete scegliere con dei gruppi di esami in cui dovete muovervi. Già questo vi dà una qualità adeguata, diciamo, anche per il mondo del lavoro. Noi facciamo regolari incontri con il mondo del lavoro, con rappresentanti di aziende, e ci danno delle indicazioni importanti, ad esempio in merito, beh, visioni generali, ma anche questioni molto di dettaglio della serie qual è il linguaggio di programmazione che interessa dopo a loro in questi ambiti. Vengono fuori cose interessanti che c'è un'enorme necessità, a parte per quelle cose che dicevo prima, come la biometria, naturalmente l'elaborazione delle immagini, ma anche c'è un enorme interesse, diciamo, sull'aspetto dei sensori elettrici, di capire come funziona un sensore elettrico e poi essere in grado di elaborare le informazioni che da esso vengono fuori, quindi anche la parte di strumentazione. E noi, insomma, adattiamo anche gli insegnamenti in questo senso e anche qui. Spero di averle risposto. Prego.
Io riguardo di crescita.
Sì.
Cioè, quanto si segue, quanto sono gli studenti che scelgono magari per quello piuttosto fare progetti di ricerca
Sì.
all'università.
Allora, io, a parte essere anche in questo momento presidente del corso di studio in ICT per Internet e Multimedia, mi sono dimenticato di dirlo all'inizio, ma negli anni scorsi ho anche fatto da supervisore, diciamo, proprio delle internship, quindi ho visto un po' tutte le internship passarvi davanti, con anche richieste da parte degli studenti se avevano delle richieste particolari, esigenze particolari. Devo dire che noi facciamo un evento all'anno a novembre dedicato alla presentazione in aula, cioè quindi con le persone qua, rappresentanti delle aziende che vengono qua da noi, fanno delle anche micro presentazioni alla fine 5 minuti perché dedichiamo 2 ore, abbiamo un bel numero di aziende che vengono e quindi dobbiamo un po' impacchettarle. Poi dopo rimangono lì e parlano con gli studenti, quindi lì c'è un momento importante in cui c'è una chiara offerta, diciamo, di internship agli studenti da aziende che sono particolarmente interessate, infatti vengono qua, mandano delle persone qua a passare 2 ore con voi, studenti. Oltre a questo, io no, ci sono degli eventi di Ateneo che fa ogni anno diciamo, un evento in fiera in cui di nuovo ci sono le aziende che si propongono agli studenti. C'è un altro evento che fa il Dipartimento, a livello di Dipartimento, quindi in cui ancora vengono messe in campo delle cose, e poi ci sono le aziende che mettono sui siti dell'Ateneo, il Career Service, le loro offerte in termini di internship. Se questo non bastasse, poi per fortuna, cioè nel senso poi c'è la creatività dei singoli studenti, il passaparola e chissà quali strani meccanismi, per cui ci sono anche molti studenti che arrivano con una loro internship dicendo ho trovato questa azienda che mi vuole per fare questa cosa e chiedo che mi sia riconosciuto come internship, eccetera, eccetera. Sì. Qualcuno chiede aiuto, ma di solito quando io poi rispondevo, intanto appunto contatta le aziende, guarda tutto questo materiale, perché poi a questi eventi corrisponde del materiale che noi lasciamo comunque a disposizione nel tempo e quindi uno può capire cosa c'è, quali sono i contatti, eccetera. La cosa, diciamo, si risolve bene. Bisogna un po' navigare in queste informazioni e andare a cercare le informazioni quando servono. La parte di scienze logiche appena citato è un corso che sarebbe più affine. Allora, noi abbiamo un corso di strumentazione, ad esempio, che è presente lì, che senz'altro va bene, quello senz'altro il più affine, poi io ve l'ho citato solo come esempio, nel senso che poi la distanza che c'è e le differenze, le richieste che uno trova nel mondo lavorativo sono poi diverse, e questo sempre è stato così e sarà sempre così. È impensabile che in 2 anni, anche 5 se volete, prendendo anche i 3 anni precedenti, vengono fuori delle persone che sono pronte per la enorme varietà di attività lavorative, perché io vi ho mostrato, ripeto, quei 2 esempi, ma avete visto che già in quei 2 esempi c'erano diverse caselle ed erano tutte un po' diverse, richiedevano tutte competenze un po' diverse, e queste erano molto centrate su quello che facciamo. Quindi la varietà è molto elevata. Il corso di strumentazione che abbiamo potrebbe essere utile in questa direzione. Ho risposto a una domanda da casa, ho risposto anche a lei. Ci sono altre domande? Bene, il collega di elettronica che è già qua, quindi tra poco ci sarà la presentazione del suo master. Io rimango qua ancora un po', se avete domande. C'è la registrazione, sperando che sia andata a buon fine, che abbiamo fatto, che metteremo a disposizione assieme alle altre registrazioni di master. C'è il sito, questo qui, a cui potete fare riferimento per avere approfondimenti sul curricula e altre cose. Lì trovate anche i contatti per scrivere e poi anche incontrarsi di persona, se volete incontrare qualcuno di noi specificamente, chiedere supporto e consiglio su quale percorso scegliere, come muovervi, siamo a disposizione. Grazie. Ok. Allora, che è connesso da casa o da fuori, adesso io mi stacco, ma poi ci riconnettiamo tra un attimo per la prossima presentazione.